through some questions here to start, and then we'll finish up chapter 4, and then that'll be our day. Sound cool? Joe?
Can we do a worksheet 2? We'll do a second problem on the first set of problems.
Number 2?
Yes.
Sure. So this one right here.
Yes, sir.
Okay. So what we'll do is, first thing I'm going to observe that my answer that I'm going to be getting is going to be a positive value for theta. I know it has to be positive because it's between 2 pi and 3 pi, which are both positive numbers. So since it's positive, when I draw my picture, I'm going to be going counterclockwise. So I'll start 0, pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi. So between 2 pi and 3 pi is quadrants 1 and 2. So far, so good. I'm going to use all silly turtles crawl to determine where cosine is positive between quadrants 1 and 2. The A in all tells me all of my functions are positive in quadrant 1. So there is my theta. So far, so good. So my alpha is going to be the acute angle formed between the x-axis and my terminal side. So that's my alpha. And since theta was positive, and the last axis I pass through when I draw my theta is the horizontal, I can say that theta is going to equal 2 pi plus alpha. So it's plus alpha because theta is positive, and the last axis that I pass through when drawing my theta is the horizontal. It's 2 pi because the part that makes up my, or the part of the x-axis that forms my alpha is going to be whatever I'm adding or subtracting from. Okay. And the alpha that I'm using is going to just be cosine inverse of the absolute value of 0.56. And it's calculator time, my dudes. So 2 pi plus cosine inverse 0.56 gives me about 726. I can check that answer. So if I do cosine, regular old cosine of that answer, it better give me 0.56. It does. And that 726 better be between 2 pi and 3 pi. So 2 pi is 6.2 yada yada yadas. So it's bigger than that. And 3 pi is like 9.3 or 4 yada yada yadas. Smaller than that. So I got my answer. So we're good to go there. Does that feel all right, Joe?
Bueno.
Jay?
You do number 6 on worksheet 1.
Sure. Worksheet 1, I also would need, for the directions, I need the unit circle, so I'm going to grab that also real quick here. Right quick. Okay. And you said which one again, Jay? 6. Oh, okay. So this is actually the easiest version because there's not because I can go specifically to what I want.
I need to like recount the bunches we got. Can I like calculate?
Sure.
Okay.
So on the unit circle, sine is y, right? And x is cosine. So I'm just going to go to my unit circle and find the place where I have the x coordinate is 1/2 and the y coordinate is negative root 3 over 2. Well, I mean, it's, if you hadn't done it before, you know, like, it's okay. So 1/2 negative 3 over 2, so 5 pi over 3. And that's it. Cool. NBD there, I hope. Right? Had worse or seen worse. Who's next? Joseph.
Did you do number 9 on the same worksheet?
Sure. Sure.
1.
This one is worksheet 1. You said 9 or 10. I
Oh,
forgot.
number 9, please.
I missed it. Oops. Number 9. Okay. So we'll start by drawing our picture. So again, we're noticing we're positive, so we're going counterclockwise. So we're looking in quadrants 2 and 3. If I do all silly turtles crawl, I have to remember that cotangent is the reciprocal of tangent. So wherever something is positive, its reciprocal is also going to be positive. And if it's negative, its reciprocal also is going to be negative. So basically, I'm just looking for where tangent is going to be negative.
So is that the second S?
That's in the second quadrant. Very good. So there's my theta. So I know wherever I'm looking on the unit circle, it's going to be in the second quadrant. So I remember that cotangent is x over y. If I multiply both sides by y, I'm basically going to be looking in the third quadrant, or I'm sorry, the second quadrant, where the x and y coordinates are opposite. So I look at that. So right there's where I'm looking for, 3 pi over 4.
Okay.
Jack?
This is not one of the questions, but can you rewrite with the chart, like the cotangent, tangent, or is it even?
Do you mean them in terms of x and y, or like there's lots of different
Yeah.
definitions we've had for
In terms
these?
of X and Y.
Okay. So if we were looking at our unit circle, the points are cosine, comma, sine. So cosine's x, sine is y. Tangent is y over x. So cotangent, it's its reciprocal, would be x over y. Cosecant is the reciprocal of sine, so that's 1 over y. And secant is the reciprocal of cosine, so that's 1 over x. Is that what you needed?
Yeah.
No problem. And this is all stuff we did in chapter 2, right? Shannon.
Could you do number 12 from worksheet 1?
You're not Shannon, you're Stephanie. Dang it. Which one?
Number 12.
From worksheet 1?
Yeah.
My apologies. Okay. So we'll start by drawing a picture. I'm not going to write down I'm just going to kind of do the counting and then just start writing in when it matters because we're going to go around a lot of times here. So 0, half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5, 7, 7.5. So we're looking in quadrants 2 and 3. Cool? All silly turtles crawl. I know cosecant is going to be negative or positive in the same places that sine is negative and positive because those are reciprocals. So in this case, that means quadrant 3. So 2 pi, 4 pi, 6 pi, and then on to my answer. So here, I know that cosecant is equal to this, and I know sine is the reciprocal of cosecant. So really I can say I'm looking for sine is equal to the reciprocal of the square root of 2. And here I would rationalize my denominator. So really I'm looking for the place in quadrant 3 where the y-coordinate is negative root 2 over 2. So I go to my unit circle. So I'm looking there at 5 pi over 4. But 5 pi over 4 is not actually my answer, because to get to 5 pi over 4, I actually went 1, 2, 3 times around before I got to 5 pi over 4. So I should be adding 2 pi to that 3 times, 1 time for each full revolution. So to add those fractions, I need to make a common denominator. What would the common denominator be in this case? 4. So I'd multiply 2 pi over 1 by 4 over 4. So those all turn into like 8 pi over 4. To add fractions, we add the numerators. 5 plus 8 plus 8 plus 8 is 29 pi's, and the denominator stays the same. So 29 pi over 4 should be my answer there. And remembering that you had to add all those 2 pi's at the end would have been the trickiest part there. Right? Easy to forget that. Jay.
Worksheet 2, number 10.
Worksheet 2, number 10.
Run to the bathroom real quick.
Yeah, you can actually walk if you want.
Thank you.
Ha 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 ha.
Your own safety, Joe. Put that hustle in, bro.
Maybe he needs to run. I don't know. Could be an emergency. Doesn't want to have a poopsident. Is that funny? Yeah, it's pretty good. All right. First thing I observe here is that the theta is negative, right? It's in between 2 negative values. That tells me that when I'm labeling, I got to be going counterclockwise. And again, I'm not going to write down every label because we go around a couple of times and it's going to get a little messy. I'm just going to write in the ones that mattered for us. So 0, negative a half, negative 1, negative 1.5, negative 2, negative 2.5, negative 3, and then negative 3.5. So we're looking at quadrants 2 and 3. So far, so good? Okay. All silly turtles crawl. So sine is negative in which of those 2 quadrants? Quadrant 3. The S is tells us sine is positive there. So we need to actually be in the other quadrant. And when we draw our theta, we need to make sure we're drawing clockwise also, right? Because theta is negative. So -2 and then to our answer. So there's my theta. So my alpha is here. Since theta is negative and the last axis I passed was vertical, I'm going to be adding alpha. And I'm going to be adding alpha to the other, or the end of the x-axis that alpha uses. So -3 pi. Where alpha is just sine inverse, absolute value 0.44. Or -0.44, I should say. Well, they're the same, right? Absolute value of 0.44 and -0.44 still give us the same value. But whatevs. I'm going to do the absolute value just in my head because it's way less buttons to push in my calculator, and I can certainly make something drop a negative sign in my head. That's pretty easy to do.
Alpha -2 pi.
No, alpha is the sine inverse of the absolute value of -0.44. What I wrote right here. What was that again? 8.97. Jay, does that feel okay? And just to run through that one more time, whether you add or subtract, if theta is positive, we do one set of things, and if theta is negative, we're going to do the opposite. If the last axis passed was vertical, we're subtracting. If it was horizontal, we're adding. And if theta is negative, it's just the opposite. Right? So again, I think we've written that down a couple of times. But Leo!
My question was just if we had to memorize that. And will you give that to us on our homework, please?
No.
Okay.
You'd want to know when you have to add or subtract alpha. Yeah, for sure. For sure. Because it's not really a formula, it's just something we've made up that makes it easy to, rather than looking at the picture to write the equation. It's not like a formula we've developed, it's just kind of like some facts. Jack.
Negative.
What was that, Mumbles?
Oh, sorry. I want to do the negative, like number 12.
Sure. Okay. So I'll start by drawing our picture. Again, observing that this is negative. We're going to be labeling clockwise around. And again, since these are pretty big values, I'm not going to put all the labels on there. I'm just going to start labeling when it matters. So 0, -0.5, -1, -1.5, -2, -2.5, -3, -3.5, -4. So we're looking at quadrants 1 and 2. We go to all silly turtles crawl. Tangent is positive in the first quadrant where everything is positive. And then to draw this, we're going to draw, again, since theta is negative, we're drawing clockwise. So round to -2, and then to my answer. My alpha, always the acute angle between the terminal side and the x-axis. Since theta was negative and the last axis we passed was vertical, what are we going to be doing this time? Adding or subtracting? Yeah, this is an adding. If theta was positive, we'd be subtracting. And what are we going to be adding to? The other end of the x-axis that makes up alpha. So negative 4 pi. And alpha in our case is tan inverse, absolute value 1295. That's calculator time. Again, I'm not going to type in the absolute values. I'm just going to do those in my head on my calculator. So I get negative 1107. And all these problems that we've been doing, these are all checkable, right? You guys know this. How you check them, you can use your calculator. So what I'm going to do is I'm going to take the tangent, regular tangent, of my answer and make sure I get 1295. Which I do. And the other part of my check is I have to make sure that negative 1107 is between negative 4 pi and negative 3 pi. So it's bigger than negative 4 pi and smaller than negative 3 pi. So I'm sure that I have the right answer, since it satisfies the equation and fulfills the inequality. That's just the checking. Any of these are checkable. You do them all the same way. Is that okay? You guys feel a bit better? Or maybe the same? Hopefully not worse. Unless it's like, yo, I got a lot of work to do. Like, but I'm glad I know that I have a lot of more work to do. Which is still probably better.
How this help?
Yeah. Probably couldn't hurt, right? All right. Still doing, everybody ready to move forward then? Okay. We're going to do section 4.2 today. We're only doing the 2 sections of chapter 4, so we're done with chapter 4 after today. Just as an FY to the I.
Not gonna be that.
No, there's going to be a test on chapter 4, but
I'm talking like it's gonna be quiz or it's gonna be test.
it's not a test, my homie. It's okay. You can ask those questions. I can be like staggered by the fact you're asking them, but you can ask them. No big deal. Nobody gonna be mad about it. Yeah, that's the question you don't ask, right? Okay. So 4.2, we're going to be talking about story problems involving these trig functions and whatnot. We're going to start with a pair of definitions. So the 2 terms we're going to start by defining is the angle of elevation and then the angle of depression. And I'm not going to define these 2 terms with words. I'm just going to kind of draw a picture, because that's really what we're going to be using this vocabulary to do in this section, is drawing some pictures. So let's say we have one person that's like kind of standing at ground level, another person standing at some elevated position. Everybody okay with that scenario? If you're just standing there, you're just kind of looking straight ahead. It's like your line of sight is straight ahead, right? Whether you're at on the floor or if you're up on the cliff here. Either way, like your natural line of sight is just kind of looking straight ahead. Now let's say you're the person on the bottom. What you're going to do is you're going to tilt your head up to look at the person on the cliff. So your line of sight is moved to like here. So you've moved your line of sight in that direction, right? That change is called your angle of elevation. I'm using AOE to abbreviate angle of elevation. Hopefully that was clear, but I'll say it again just in case. Now, if you're the person on the cliff and you want to look down at the person on the ground, you've taken your line of sight and you've lowered it this way. That change is going to be your angle of depression. So you've taken your line of sight and you lowered it. That's an angle of depression. Number one mistake students make. That spot is not the angle of depression. Or I put the green star. That's a bunch of nonsense. There's nothing, none of them go there. Everybody's okay? It's always between your line of sight and the other person. It's never between like a vertical and, the person or whatever. Everybody's okay with that? Geometrically, if we look at the angle of depression, the angle of elevation, what can we say about those two angles?
They're acute, they make a triangle kind of.
Well, in this case, sure, they have to be acute if they're between a line of sight, but even more so than that,
What's the question again?
geometrically, what can we say about the angle of depression, angle of elevation?
They're the same.
They are the same. They are congruent. Why are they congruent? That is correct.
It's like that rule that we learned somewhere.
And-
I forgot.
Yeah. They're called alternate interior angles. If you have two parallel lines that are cut by a transversal, alternate interior angles are congruent. You don't need to remember all that vocabulary or the theorem stated that way, but you should remember that, those two angles are the same. That's enough for me. Again, the parallel lines are the two line of sights, right? Like those are the parallels. Your transversal is this. And there's 4 different parallel line theorems that apply to that sort of situation, but the one that we're concerned with here is that alternate interior angles theorem. Again, would never ask you for that vocabulary, but geometry was a long time ago. These things matter. They show up on ACTs and stuff like that presumably some of us are still taking. So, worth making mention of it. Everybody okay? All right, let's use this now in a problem. So let's say that we have the following situation. Christy is looking up from looking up at the Fisher Building in downtown Detroit. She's standing 200 feet from the base of the building and finds the angle of elevation to the top of the spire to measure 66 degrees. How tall is the Fisher Building? Well, let's start by just kind of drawing a picture. So we're told we're 200 feet away from the base of the building. And our angle of elevation, so we start by looking straight forward. And then we look up. So our angle of elevation here is going to be 66 degrees. Everybody feel cool with the picture we've drawn? What I'm going to do is I'm just going to translate this into a simplified picture here. Just a triangle. And again, if you're comfortable doing that, you can go straight to the triangle. And then we're asked how tall is the building, so we're looking for this side X, right? Notice when I drew this triangle, I made it a right triangle. Why can I assume this is a right triangle? This is a real world question. Why can I assume that that triangle I drew is a right triangle? What's up?
It's a wall or whatever. it is.
Yeah,
Building.
it's a building and the ground. Buildings are typically perpendicular to the ground, right? There's one building of note that is not. Leaning Tower of Pisa, right? Unless it's explicitly stated, though, you can assume anything that's on the ground is going to be perpendicular to the ground, because that's typically how things work, right? Buildings tend to fall down otherwise. Okay, so we have this right triangle. We know one of the sides and we know one of the angles. What can I use to find that other side length there, that side length x inside of this right triangle?
We've done this before.
We have done this before.
Can't we use like tangent, like SOHCAHTOA? Yeah.
Yeah, we're going to use SOHCAHTOA. So this is called right triangle trig. We've done this a little bit already this year, and you should have done it in your geometry class a millennia ago. So to figure out which one I need, sine, cosine, or tangent, I'm going to consider the angle that I know. Relative to that angle, the side I know is, what is that? Is that opposite, adjacent, or hypotenuse? Adjacent, because it's part of the 66-degree angle. And the side I want to know is it opposite or hypotenuse? Opposite. So if I have opposite and adjacent, which trig function should I use?
Opposite and adjacent?
Mm-hmm.
Tangent.
Tangent. So I'm going to do tan 66 is equal to opposite over adjacent. Everybody cool so far? To solve this for x, I'll multiply both sides by 200 to get rid of the fraction. And then it's calculator time. Before I start punching this into my calculator, though, what do I need to make sure that I check? Yeah, my mode. I need to make sure I'm in which one? Degrees or radians for this problem? Degrees. How do I know it's a degrees problem?
Because we have an angle.
66 degrees, right?
I feel like every time we use the calculator, it's been radians.
Right.
By default.
You have been. It has been so far, but this problem, the angle was given to us in degrees. It says like 66 degrees. So I know that I need to be in degrees. This test can be kind of a nightmare in terms of switching things back and forth because you'll have problems that are both in radians and degrees. So you'll have to be mindful of it. Okay, so 200 times tan 66. So I get 449.2 is my value for x. That's it. That's not too bad, right? Let's do another. So this says, Jane has climbed a tree and is looking down on her friend Mary. Jane has climbed 17 feet in the air, and the angle of depression to Mary is 49 degrees. How far is Mary standing from the base of the tree? So let's start by drawing our picture. Yeah, what's up, buddy?
I'm going to warn you because this might be like one of the dumbest things we've ever said. So on the last one.
Yeah, okay. I'm excited to hear this.
Yeah, no, I don't know why I thought of this, but we were trying to find the opposite side.
Yep.
And we already had the adjacent.
Yep.
And if I'm like eyeballing it, the adjacent side is longer than the opposite. So how come the longer the?
Sure. Here's what I'm going to say.
Okay. You get what I mean though? Okay, yeah, alright.
Not to scale. That angle's not 66 degrees. That other side's not relative 200 feet. Nothing is to scale. I just wanted to draw a triangle to hold the information down so I can figure out sine, cosine, or tangent is the one that I needed.
Okay.
So nothing I'm going to draw is going to be to scale. I'm just kind of scribbling some pictures. Cool?
Yeah.
Fair question though, right? On the ACT, would they do that to you?
Never know.
Probably not. Their pictures are, they say they're not to scale. They're to scale.
Yeah, they are. Yeah.
So like you can do some eyeballing and be like, yo, that answer is not even reasonable because look at this piece I'm solving for. That's way too big or way too small. But yeah.
I got that ACT thinking, you know.
Yeah, not unfair question. Yeah, I drew a stupid picture, but it's okay. All it needed to be was figuring out which one I need to use. Jay. Sure. All right, let's see. Jay has climbed a tree. Okay, let's draw ourselves a tree. Look, I even used green. And here's our pal Mary, so J, M. We're 17 feet up in the air. And the angle of depression, so here's our line of sight. Here's that, is 49 degrees. So that's where the 49 goes. That's the place where it's real tempting to put it over here. It doesn't go. The 49 does not go there. Your angles of elevation and your angles of depression are never between the line of sight and a vertical. Everybody's cool? I'm going to warn you to you because this is the number one mistake I see students make when they have to draw their own pictures, is they put that angle of depression in the wrong spot. Okay. Everybody feel good about this picture we've drawn? And we're looking for this. How far are we from the base of the tree? So I'm going to translate this into a picture or into a triangle. Why can I assume this is a right triangle? Tree grows perpendicular to ground typically, unless it's like some goofy half-dead fallen over tree, but we're going to assume that it's just straight to the ground unless it tells us otherwise. Everybody cool? So we know this side is 17 feet. This side is X. Where's the 49 go? I guess I can put M and J.
Would it be the bottom left angle?
Yeah, so I know that this angle and this angle are the same. So the 49 that I drew in the picture is not actually part of the triangle that I drew, unless I know that alternate interior angles are congruent. Everybody's cool? Okay. SOHCAHTOA time again. So relative to this, to the angle 49, what is the 17? The side I know. Is that opposite, adjacent, or hypotenuse?
Opposite.
Opposite. And the side I want to know, the X, is adjacent or hypotenuse?
Adjacent. Oh, well,
Yep.
that's the hypotenuse. No, it's not. It's adjacent.
It's adjacent. So which trig function should I be using here?
So, sine. Wait, opposite. So, opposite over hypotenuse. No, it's cosine. No, it's not.
It's tangent.
Jeez, man. It's Friday. It's been a long week.
There's three options and you got
I know.
Yeah.
I'm trying to do this all
You
better.
said the two like 4 times.
Really wanted to use that hypotenuse. Just really wanted it. All right.
It's the longest side.
So we have
Yes.
tangent 49 equals opposite over adjacent. To solve for x, I'm going to multiply both sides by x to get rid of the fraction. And then I'm going to divide both sides by tan 49. Remember, tan 49 is just some goofy decimal, right? I could type it in my calculator and get the decimal, but like, I don't want to have to keep track of all those decimal points. I'm just going to call it tan 49 until it's calculator time. Everybody cool? Okay. 17 divided by tan 49 is 14.8 feet. that's all she wrote here, kiddos. Sound good? Okay. So worksheet 3, you guys should be able to do 1 through 4. I'm not going to ask you to worry about problems 5 or 6. I put an X in the content library there so you remember not to do them, but if you already downloaded the worksheets, that's not going to help you right now. And you guys should be able to do the problems on the homework set 19 to 23. We're not going to worry about any of 24 through 31. Okie doke. If you consult the board here, I have that worksheet 3 and 19 through 23 are all part of next week's problem set, not the problem set due on Sunday, but the following week's. Sunday, what we're looking for is worksheets 1 and 2, and then 1 through 18 from the problem set. Next class, we'll do our homework quiz. We'll spend a review day. And I have the tests scheduled for Thursday and Friday next week, respectively. So we'll probably start. That would mean that, yeah. So we'll have a review day. The next day we'll take some questions and then start chapter 5, and then the next day is the test. So you'll have like a day in between there. Everybody cool with that plan? I think all those dates are up on My Notre Dame and all that for you. Leo?
So our homework is worksheet 3 and 19 through 24?
23.
23, okay.
Yeah. Yeah, nothing from that second page of the problem set you are going to be doing.
Okay.
Oh, you know what? Not even 23. We're not doing 23 either. I lied. 22. Yeah, good. Just to 22. Okay? Let's stop